Good morning, class. I trust you are well today and energized. Today, I will be taking you through the revision of trigonometry. Now, what I need from you is to grab a pen, paper, and your calculator. Let me give you a few minutes to organize yourself. So today, I'll be taking you through again the basics of trigonometric ratios. That's what we're going to first start off with. So imagine if you have a right angled triangle. Kindly draw that for me. So with the right angled triangle, you've got your 90 degrees, and on one angle, you've got theta. We will use this triangle to identify or simplify our trig ratios. So if we have sine theta, they are equivalent to the opposite length divided by the hypotenuse length. Cos theta is equivalent to the adjacent length divided by the hypotenuse length. Tan theta is equivalent to the opposite length divided by the adjacent length. Now, it is also equally important for you to know the inverse of these ratios and know how you can simplify them if they pop out in the exams. If you have cosec theta, which is the inverse of sine theta, you can express it as the hypotenuse length divided by the opposite length. Sec theta is the inverse of cos theta. You can simplify it by saying the hypotenuse length divided by the adjacent length. If you have cot theta, which is the inverse of tan theta, you can express it as the adjacent length divided by the opposite length. Now, it is equally important for you to know which quadrant an angle lies in and which ratio is positive then. So in the first quadrant, we know that all trigonometric ratios are positive here, right? And then the angles belonging in first quadrant is theta, and then also 360 degrees plus theta. In your second quadrant, the trig ratio that is positive and its inverse here, it is sine as well as cosec here. So sine theta is positive in this quadrant, the second quadrant, and also cosec. Now, when we look at the angles in the second quadrant, the angles that belong in the second quadrant is 180 degrees minus theta, as well as negative 180 degrees minus theta. In the third quadrant, tan is positive, as well as cot. Now, the angles that belong in the third quadrant is 180 degrees plus theta, as well as theta minus 180 degrees. In the fourth quadrant, we have cosine being the only positive ratio here. And the angles belonging in this quadrant, it is 360 degrees minus theta and negative theta. Now I will be taking you through the reduction formulas. So in the second quadrant, say for example, you're given sine 180 degrees minus theta. If you apply the reduction formula, you will get sine theta. If you have cos, open bracket, 180 degrees minus theta, close bracket, it is equivalent to negative cos theta. If you're given tan, open bracket, 180 degrees minus theta, close bracket, it is equivalent to negative tan theta. We move on to the third quadrant. Third quadrant, remember, we mentioned that the angles that belong to the third quadrant is 180 degrees plus theta. So if we are given sine, open bracket, 180 degrees plus theta, close bracket, this is equivalent to negative sine theta. If you're given cos, open bracket, 180 degrees plus theta, close your bracket, it is equivalent to negative cos theta. Tan, open bracket, 180 degrees plus theta, it is equivalent to tan theta. Now, in your fourth quadrant, same thing applied. So you've got sine, open bracket, 360 degrees minus theta, close bracket. You have negative sine theta. Cos 360 degrees minus theta can be expressed as cos theta. And tan theta minus theta, tan 360 degrees minus theta, apologies for that, is equivalent to negative tan theta. So with these, we have applied our reduction formulas. Now, where do you use reduction formulas? Reduction formulas are used in proofs when you are required to prove trigonometric equations or simplify trigonometric expressions. It is important for you to know how to apply these reduction formulas so that you can get the most marks. Next concepts that are also called reduction formulas would be our co-ratios, or also called co-functions. These are as follows. Remember that we have 90 degrees minus theta, which I said that it is in the first quadrant, right? So sine, open bracket, 90 degrees minus theta, close bracket, is equivalent to cos theta. Cos 90 degrees minus theta is equivalent to sine theta. Tan 90 degrees minus theta is equivalent to cot theta. Now, when we move along to 90 degrees plus theta angles, which lie in the second quadrant, sine 90 degrees plus theta can be expressed as cos theta. So its co-ratio is cos theta. Cos 90 degrees plus theta is negative sine theta. And then tan 90 degrees plus theta is equivalent to negative cot theta. So kindly know these co-ratios because these are critical in the exam and they are not provided in the formula sheet. Next concepts that I would like to take you through are the special triangles. Now imagine you've got a right angle triangle and the angles inside the triangle, one angle is 45 degrees and the other is 45 degrees. So let us use 45 degrees as our reference angle, right? The opposite side of 45 degrees is 1. The adjacent side of 45 degrees is 1. And our hypotenuse is square root of 2. Now, we're going to move on to the second special triangle. Imagine you have a triangle, a right angle triangle, and the reference angle is 60 degrees. So the opposite side of 60 degrees is square root of 2. Square root of 3, please correct there on your graph, it's square root of 3. The adjacent side is 1. The hypotenuse is 2. And then your third special triangle has got a reference angle of 30 degrees. Now its opposite side is 1. Its adjacent side is square root of 3. And its hypotenuse is 2. Now we are moving over to identities. The first identity I'll be taking you through is something you learned in grade 10. This is a refresher. So these are also in your formula sheet. So we need you to know how to apply these. So I'll take you through them one by one. So first identity is tan theta. You can express it as sine theta divided by cos theta. If you're given cot theta, you can express it as 1 over or 1 divided by tan theta, or you can write it as cos theta divided by sine theta. Square identities. If you're given sine squared theta plus cos squared theta, it is equivalent to 1. From this follows that you can express cos squared theta as 1 minus sine squared theta. Then if you have sine squared theta, you can express it as 1 minus cos squared theta. So note that the two identities that I've mentioned can be both factorized as difference of squares. So for example, we mentioned that cos squared theta is equal to 1 minus sine squared theta. You can express it as difference of two squares. So what we'll have in the first bracket is 1 minus sine theta. Second bracket, 1 plus sine theta. Then if we're given sine squared theta equals to 1 minus cos squared theta, we can express it as open bracket 1 minus cos theta. The next bracket we have 1 plus cos theta. I hope you have that jotted down, friends. Wow, it was a mouthful. Let us just digest, right? Go over all that I've taught you thus far and make sure that you understand them. If you don't understand how to apply them, go to communicate with your peers or your teachers at school. All right, next topic we will be covering is compound angle identities. So if we're given cos, open brackets, alpha minus beta, that is equal to cos alpha times cos beta plus sine alpha times sine beta. If you're given cos, open bracket, alpha plus beta, it is equivalent to cos alpha times cos beta minus sine alpha times sine beta. Number 3, sine, open bracket, alpha plus beta. You can write it as sine alpha times cos beta plus cos alpha times sine beta. 4, sine alpha, open brackets, alpha minus beta. You can write it as, or it's equal to, sine alpha times cos beta minus cos alpha times sine beta. Fortunately, these are given to you in your formula sheets, so you don't have to know these off by heart. We will move on to double angle identities. So if you're given sine 2 alpha, you can write it as 2 sine alpha times cos alpha. If you're given cos 2 alpha, it is equals to cos squared alpha minus sine squared alpha. Cos 2 alpha can also be expressed as 1 minus 2 sine squared alpha, or 2 cos squared alpha minus 1. If you're given tan alpha, you can express it as 2 tan alpha divided by 1 minus tan squared alpha. So I'll be taking you through the tips for proving identities. Now, when you are asked to prove an identity, kindly write these tips for yourself so that you can use these tips as you practice proving identities. Number 1, work with your left-hand side and right-hand side separately. Number 2, write double angles as single angles. Number 3, watch out for square identities. Number 4, write everything in terms of sine and cos. Number 5, when working with fractions, put everything over the lowest common denominator. 6, be on the lookout for opportunities to factorize. For example, if you're given 2 sine alpha cos alpha minus sine alpha, you can simplify it by factorizing out sine alpha. So what you'll have is sine alpha times open bracket cos alpha minus 1. Next example, if you're given cos squared alpha minus sine squared alpha, you can express it as cos open bracket cos alpha plus sine alpha open bracket cos alpha minus sine alpha. Let me repeat that again. So if you're given cos squared alpha minus sine squared alpha, you can express it as, or factorize it and say, open bracket cos alpha plus sine alpha times open bracket cos alpha minus sine alpha. Next example, if you're given 2 sine squared alpha plus sine alpha minus 1, you can express it as, open your first bracket, 2 sine alpha minus 1 multiplied by the second bracket being sine alpha plus 1. It is sometimes necessary to replace 1 with sine squared alpha plus cos squared alpha. Remember that identity? Yes. Sometimes they will trick you and put a 1. So what you can do is replace the 1 with sine squared alpha plus cos squared alpha. Let me give you an example. If you're given sine 2 alpha plus 1, you can express it as sine 2 alpha times cos alpha plus sine squared alpha plus cos squared alpha. If you can see what this is, this you can simplify it and say sine open bracket sine alpha plus cos alpha close your bracket squared. Very interesting, right? So the next portion that I'll be taking you through is finding the general solution of a trigonometric expression. So I would like to take you through examples of how to apply all the steps, right? Can you please have your pencil, paper, and calculator ready if you don't have already? Now, what we have here so the first example I will take you through is if we have been given a general solution that goes of this, or a trigonometric equation that says, find the general solution of 2 sine 3x is equal to 0.4. The first thing you need to do is to get the trig ratio alone on the left-hand side. So what do? We need to divide both sides by 2. So what we will be left off with, sine 3x is equal to 0.2. Why? 0.4 divided by 2 gives us 0.2. Right? Then, next step of finding the general solution for this equation here. As you may note on the right-hand side, the sign of 0.2 is positive. So this indicates that the positive indicates that the first and second quadrant are where sign is positive, right? So we know that we're looking at angles in the first and second quadrant. So with that being said, our reference angle is 0.2. But now, how do we get it? How do we find the actual angle? So we need to use the ratio of 0.2. So please take your calculator and click second function, sine. Inside your bracket, insert 0.2. What do you get? Yes, 11.54 degrees. I have rounded that up. That will be your reference angle. Next step, as I've mentioned previously, that sine is positive in the first and where? The second quadrant. First quadrant, we know that we have theta only as the reference angle. And then in the second quadrant, we have 180 degrees minus the reference angle. So our first step, we're going to focus on the first quadrant. And then later, the second quadrant. Let's start. First quadrant, what do we have? 3x is equal to 11.54. Remember, 11.54 is our reference angle. Plus k times 360 degrees, semicolon, k element of integers. Now, once we have this, we need to make sure that we are solving for x. We need to divide the entire equation by x to isolate x. So basically, when we do that, we're going to say 3x divided by x is equals to 11.54 divided by 3 plus k times 360 degrees divided by 3. What do you get? Yes, we get x is equals to 3.85 degrees plus k times 120 degrees. That's the first quadrant. Now, second quadrant, what do we have? We've got 3x is equals to 180 degrees minus 11.54 degrees plus k times 360 degrees. This is equivalent to x is equals to 56.15 plus k times 120 degrees. I hope you know where that comes from. So again, when we are at this stage, we need to solve for x. And these are our final answers for the equation 2x, 3x is equals to 0.4. So our general solution is exactly that. Next example that I have for you is, for example, if we were given 1/3 or a third times cos x is equal to negative 0.2. Again, we need to make sure that we get the ratio, our trig ratio, to be alone on the left-hand side. So tell me, what should we multiply by? Yeah, we need to multiply by 3. Yes. So we will have 1/3 times cos x times 3 is equals to negative 0.2 times 3. Interesting. So what we'll end up with, we'll have cos x, because 1/3 times 3 is 1. So we'll have just cos x is equal to negative 0.6. Now, when you look at this equation here, can you see that we've got a negative ratio, negative 0.6? The negative indicates that the second quadrant and third quadrant are where cos is negative. So what you need to do to get your reference angle, you need to click and say second function cos of 0.6. So you take the value 0.6. The negative just points which quadrant you need to look in. The actual ratio gives you what your reference angle is. So yes, take your calculators and plug and press second function. Second function is 2NDF. And then press cos. Right? Press cos. Then insert 0.6. What do you get? Yes, you get 53,13 degrees. And that's your reference angle. So next, we look at the second quadrant and the third quadrant, which angles are there. So remember, the second quadrant, we've got 180 degrees minus your reference angle. And then the third quadrant, we've got 180 degrees plus the reference angle. Why are we using that again? Because cos is negative in the second and the third quadrant. So first things first, we're going to start off with the second quadrant. So how are we going to express this? We're going to say x is equals to 180 degrees minus our reference angle plus k times 360 degrees. Semicolon, for k is an element of all integers. Then x is equals to, remember, 180 degrees minus 53,13. We get 126,87 degrees plus k times 360 degrees. That's our general solution for the second quadrant. Now let us look at the general solution for our third quadrant. We have x is equals to 180 degrees plus 53,13 degrees plus k times 360 degrees. Now, 180 degrees plus 53,13 degrees will give us 233,13 degrees plus k times 360 degrees. So that is your general solution. I hope you're getting into the hang of this. Next example I want to take you through. I hope you guys are still energized. Let's go. So the third example, kindly write down for me 2 times tan, open bracket, x minus 10 degrees plus 3 is equal to 0. So if you're given this equation, remember, you need to get the trig ratio alone on the left-hand side. So what do? We will take the 3 to the right-hand side of the equation and then divide the entire expression by 2. So what will we have? We will have 10, open bracket, x minus 10 is equal to negative 3 divided by 2. I know you got that, my friends. If you didn't, then follow with us along. Now, the negative 3 over 2 is because we had taken the 3 to the right-hand side of the equation, which will give us negative 3. Then on the left-hand side, we're left with 2 tan, open bracket, x minus 10 degrees. Then we divide the entire equation by 2. Therefore, leaving tan, open bracket, x minus 10 degrees on the left-hand side alone. And on the right-hand side, we have negative 3 over 2. Our next step, again, is that the negative shows us where is tan negative. So we know that tan is negative in the second and in the fourth quadrant. So next place is that we need to find our reference angle. So again, your calculators, please. Second function, tan, insert 3 divided by 2, close your bracket, and what do you get? Yes, I also get 56,31 degrees. Well done. Next step, that's our reference angle, right? Next step, we know that tan is negative in the second and fourth quadrant. Now, which angles belong in the second and the fourth quadrant? We have 180 degrees minus the reference angle in the second quadrant. And in the fourth quadrant, we have 360 degrees minus our reference angle. Let me leave it for you to solve this one. Give it a try. Okay, I trust that you have given it a try. So with this one, we know that we will say x minus 10 is equals to 180 degrees minus our reference angle plus k times 180 degrees. Now, why are we using k times 180 degrees? It is because we're working with tan. Now, tan completes its full cycle every 180 degrees. That's why we're multiplying k by 180 degrees. So what will we have here? We will have, remember, 180 degrees minus 56,31 degrees is equivalent to 123,69 degrees. So what you will have is that x minus 10 degrees is equals to 123,69 degrees plus k times 180 degrees. But remember, we are solving for x. So you need to isolate x, meaning you need to bring the negative 10 to the right-hand side of the equation. So what will that give us? Correct. It will give us 133,69 degrees plus k times 180 degrees. Why? Because we added the 10 degrees to the 123,69 degrees. We have solved for our second quadrant. Now, as an exercise, I will leave you to solve the fourth quadrant. All right, that will be your homework if you have not completed yet. So next, I would like us to practice a little bit more on equations involving two trigonometric functions. Let us say they ask you to solve for x, and what you're given is sine x is equals to cos x. So what you need to do here is divide both sides by cos x. Therefore, what you will have on your left-hand side is sine x divided by cos x is equal to cos x divided by cos x. Remember, cos x divided by cos x is equivalent to 1. On your left-hand side, you're left with tan x. Remember, the identities? Yes. So what will your x be? We use the concepts of the general solution. So we will find that x is equals to 45 degrees plus k times 180 degrees, for k is an element of integers. So that is the example I wanted to take you through. So I now trust and believe that after this session, you're able to get the general solution, number one, and also you're able to solve equations that involve two trigonometric functions. Give yourself a chance to practice this. Remember, we learn maths by practicing. So kindly do that. The next example I would like to touch with you is examples of equations involving double angles. Let's say, for example, we are given cos theta times cos of 14 degrees plus sine theta times sine 14 degrees is equal to 0,715. I hope you've written that down. What can you see here? Yes, we see an expansion of double angles. Now, we can express this as cos, open bracket, theta minus 14 degrees, which is equals to 0,715. Now, remember that we are solving equations or general solutions involving double angles. So what do we need to do next? Remember our general solution? Yes? So we need to find the reference angle and look at also the sign of the ratio we have of 0.715. We can see that it is positive. So cos is positive where? In the first quadrant and the fourth quadrant. What will our reference angle be? Remember, second function, cos of 0,715, close bracket, what angle do you get? Yes, 44,36 degrees is correct. We will use this to get the general solution or solve for our angle here in the first quadrant. Then we'll do the same thing in the fourth quadrant. Let's first start off with the first quadrant. We will have theta minus 14 degrees is equals to 44,36 degrees plus k times 360 degrees. Remember, you need to isolate theta. So what does it mean? We need to move the minus 14 to the right-hand side of the equation. So we're adding 14 to the 44,36 degrees. What will we have? Yes, we will have theta is equals to 58,36 degrees plus k times 360 degrees. Semicolon, k is an element of integers. I will leave you to solve for the fourth quadrant. I am very sure that you get the gist of what needs to be done. Now, next is I will be taking you through the problems with compound angles to be done without a calculator. Just to recap, remember in our introduction of special angles, this is where the knowledge comes through. This is where you're going to apply your special triangles. So I'll be taking you through the points that you need to do when you're solving these types of problems. So point number 1, write given information in form where trig function is alone on the left-hand side. Select the quadrant and draw a triangle in correct quadrant. So two sides of the triangles will always be known. Then third point, use the theorem of Pythagoras to determine the third side. Point number 4, now work with the expression of which you need to find the value. Write all compound or double angles in terms of single angles. Point number 5, now substitute values from diagram and simplify. So let's start off with the first example. Say, for example, we are given if 13 sine x alpha plus 12 is equal to 0, and alpha is an element that, or it's an angle that belongs in the range of 90 degrees to 270 degrees. And beta is equals to 5/13, such that beta is greater than 90 degrees. So beta is greater than 90 degrees. What type of angle are we looking at? Yes, we're looking at an obtuse angle. Determine without the use of a calculator the values of sine open bracket alpha minus beta. That's the first one, right? Then B, they're asking us to, without a calculator, determine the value of cos alpha plus beta. Let us first start off with A, solving for sine alpha minus beta. So friends, let us first start off with what we have, right? So the example I said, let me just repeat what I said. So they're saying if 13 sine A plus 12 is equals to theta, and beta is equals to 5/13, then we need to solve for sine alpha minus beta. So let us first solve the sine alpha, right? So sine alpha, remember, we have 13 sine alpha plus 12. We need to move the 12 to the other side of the equation and divide by 13. So sine alpha will be equal to -12 divided by 13. So, friends, where is sine negative? It is negative in the third quadrant and also where in the fourth quadrant. But what do they tell us about alpha? That alpha is an angle between 90 degrees and 270 degrees. So they're basically telling us that it is in the third quadrant, right? So in the third quadrant, what will take on the negative value? Remember, in the third quadrant, our x values are negative, and our y values are also negative, right? So now sine alpha is equals to, again, those ratios that we talked about. Sine alpha is equals to the opposite side divided by what? Hypotenuse. So friends, draw yourself a Cartesian plane. In your Cartesian plane, sketch a right angle triangle in the third quadrant, right? So make sure that you've got 13 written as your hypotenuse and -12 written as your opposite angle of alpha. Please use Pythagoras theorem to solve what our adjacent side is. So our adjacent side, by using the formula of Pythagoras theorem, kindly do that for me. Yes. So using Pythagoras theorem, the unknown side or the adjacent side is equal to -5. So we know that our adjacent side is -5. So we can write x is equal to -5. Then now we need to use the information of cos beta to also get the unknown side, because remember, we need to determine without using the calculator the value of sine alpha minus beta. So again, take your pencil, ruler, and draw yourself a Cartesian plane. And then cos beta is equals to 5/13. That's what we're going to be using. Can you see that cos beta is positive, right? The ratio is positive. So where is cos positive? It is positive in the first and fourth quadrant, but now it is positive in the fourth quadrant. Remember, they said beta is greater than 90 degrees. So they're telling us that it does not belong in the first quadrant, but they're hinting that it belongs in the fourth quadrant. So friends, pay attention to the details. They will help you. So kindly sketch a right angled triangle in the fourth quadrant and fill in the values that you have. So remember, cos is adjacent over hypotenuse. So our adjacent side is 5. Our hypotenuse is 13, right? So 5 and 13, yes. And then now we need to solve for the unknown side. Now in the fourth quadrant, we do know that our x values are positive, and obviously our hypotenuse will always be positive. Then it means y needs to be negative because the y values are in the fourth quadrant are negative. So what do you get? Use the Pythagoras theorem. Thank you, guys. So the answer should be y is equal to -12. Do we have the information to solve our problem? Yes, we do. So we have all the unknown sides. We know the lengths of the unknown sides. Now we can solve. So remember, when we have sine open bracket alpha minus beta, we can express it as sine alpha times sine beta minus cos alpha times cos beta. Now, this is the most critical part. We need to express sine alpha in terms of its ratio, sine beta in terms of its ratio, cos alpha in terms of its ratio, and cos beta in terms of its ratio. What will we have? Sine alpha is equivalent to -12/13 times sine beta is equivalent to 5/13 minus -5/13, which is it's a ratio for cos alpha, and then cos beta we can express it as -12 divided by 13. So you can't use your calculator, friends. Remember that. What do we get? Yes, we get -120 degrees divided by 169 degrees. That's exactly what we get. So we have determined the value of sine alpha minus beta without using the calculator. Hope you understand that, friends. This needs a lot of practice. So as homework, I will ask you to solve cos alpha plus beta without using the calculator. So basically, find the value, or determine the value of cos alpha plus beta and compare notes with your friends. So I'll just give you a hint. The answer is -1. Please solve this equation. Remember, the answer is -1. Solve the equation and share notes with your friends. Thank you, class. I hope you have yourself an amazing day. And this is it for today. And I hope that you are going to take what you've learned thus far and execute it. You have still got time to practice. And remember, practice makes perfect, and we learn along the way. Thank you, friends. Do have a great evening and enjoy mathematics. That's it from me, your teacher, Noko Rampela. Bye.